Good morning, students. Today's topic is classification of ligands. First, classification on the basis of charge on ligands. On the basis of charge on ligands. Okay. So, classification on the basis of charge on ligands. First one is anionic ligands. Anionic ligands. Anionic ligands are negatively charged. They are negatively charged. Examples of anionic ligands are F minus, Cl minus, Cn minus, S2 minus, SO4 2 minus, etc. Okay. Second one is neutral ligand. Neutral ligands. What are neutral ligands? They are uncharged and electron pair donors. They are uncharged and electron pair donors. Examples are ammonia, NH3, CO, H2O, etc. Now, third one, cationic ligands. Cationic ligands, they are positively charged. Positively charged ligands. Examples are NO plus, NH2, NH3 plus, etc. Okay. Now, second categorization. Second, on the basis of density. Okay. On the basis of density. Now, what is meant by density? Density, it is the number of coordinate bonds formed by one ligand. It is the number of coordinate bonds formed by one ligand. Okay. So, first one is monodentate ligands. Monodentate. Monodentate means ligands having single donor atom. Ligands having single donor atom. Now, examples. Cl minus, then H2O, NH3, etc. are examples. NH2, NH3 plus, etc. are examples. Okay. Second, they are also called as unidentate ligands. Okay. Second is bidentate. What are bidentate ligands? In this case, ligands can bind through two coordinate bonds. Ligands bind through two coordinate bonds by the same atom. Okay, two coordinate bonds by the same atom. That is, the same atom simultaneously forming bond with coordinate bond with the central metal atom. Okay, examples: ethylene 1,2-diamine or EN, CH2, NH2, this compound EN, or ethylene 1,2-diamine. Okay, ethylene 1,2-diamine. Ethylene 1,2-diamine. Second one, glycinate. glycinate. Okay, GLY or glycinate. Another example is oxalate. OX or oxalate. C2O4. These are the examples of bidentate. Okay. Next, polydentate. Third one, polydentate ligands. What are polydentate ligands? That is single ligands having several donor atoms. Single ligands having several donor atoms. In the case of EDTA, that is ethylene diamine tetraacetate ion. It is a hexadentate ion. Okay. Ethylene diamine tetraacetate. So coordinate bonds are formed from two nitrogen atoms and here CO minus, these CH2CO minus, these 4 atoms. So it is a 6 coordinate bonds are formed with the central atom. So it is a hexadentate ligand, it's a polydentate binding through 2 nitrogen atoms and 4 oxygen atoms to the central atom. Second example is triethylene tetramine. Triethylene tetramine. The compound will be this is the compound. Triethylene tetramine. Triethylene tetramine. This is another example. Okay. Now, third one diethylene. Diethylene triamine. This is a tetradentate. Tetradentate. See, 1, 2, 3, 4. 4 coordinate bonds are formed with the central atom. Okay. Next one is diethylene triamine. The compound will be diethylene triamine. So here 1, 2, 3. 3 coordinate bonds are formed. So it is a tridentate. Okay. Now next is ambidentate ligands. Fourth one, ambidentate ligand. Ambidentate ligands. In this case, ligands which can bind through 2 different atoms to form coordinate bonds. That is the same ligand, but 2 different atoms from this same ligand, from the 2 atoms, 2 different coordinate bonds are formed. From the example, we can easily understand. So ligands which can bind through two different atoms. Only one atom at a time. Okay. Ligands which can bind through two different atoms to form coordinate bonds. See examples. NO2 minus, SCN minus. In the first case, NO2, coordinate bond is formed from nitrogen atom. Okay. First case, the coordinate bond formed from the nitrogen atom. Okay. This is called as nitrito-N. Okay. Now, in this case, second case, nitrito-O, coordinate bond formed from oxygen atom. Similarly, in the case of other example, through SCN, through S atom, okay, this is thiocyanate and it is through nitrogen atom. This is isothiocyanate. Okay, these are the examples. Next one is fluxidentate. Fluxidentate. So, what is meant by fluxidentate? Ligands having variable density. Depends upon the nature of the metal atom attached. Okay, ligands having variable density. Okay, which depends upon nature of the metal atom or metal ion attached. Example in the case of EDTA. Okay, in the case of EDTA, it have density sometimes 4 or sometimes 6 depending upon the metal ion attached. Okay. Next, on the basis of next categorization on the basis of donation of lone pair. Third categorization on the basis of donation of lone pair. Okay. So, first one is sigma donor. In this case, donate lone pairs and make sigma bond to the central atom. Okay, donate lone pairs and form sigma bond to the metal atom. Examples are H2O, NH3, etc. are examples. Now, second one, sigma bond formation and pi acceptor. That is sigma bond pi acceptor. Sigma bond pi acceptor. So, in this case, donate lone pair to the central atom at the same time making a sigma bond and accept appreciable amount of electron density from metal atom into its vacant pi or pi star orbital. Okay, donate lone pair to central atom. Okay, donate lone pair to central atom by making sigma bond and at the same time what happens? Accept appreciable amount of electron density appreciable amount of electron density from the metal atom into its vacant pi or pi star orbitals. Okay, pi or pi star orbitals. Okay, so same time sigma bond is formed and it's also a pi acceptor. Example is CO, NO, etc. Okay, these are also called as pi acid ligands. Now next category, C, pi donor pi acceptor. Pi donor pi acceptor. In this ligands, it contains pi bonds. Okay, ligands that donate and accept pi electrons through pi bonds with central metal atom. Okay, so ligands that donate and accept pi electrons through pi bonds with central metal atom or ion. Okay, example, ligands containing double bonds. Okay, C2H4, C2H6, etc. are examples. Okay, these are the different categorization. Next type of ligand is chelating ligand. Chelating ligands, it's very important. Chelating ligands. In this case, ligands resulting in close ring structure with the metal ions. Ligands resulting close ring structure with the metal ions. They form a closed ring structure. Example, ethylene 1,2-diamine. In this case, ethylene diamine is involved in the formation of cyclic ring structure with Cu2 ions. So Cu2 will be the central atom, that is CuEn twice. So Cu is a central atom and two molecules of ethylene 1,2-diamine are attached to it. See, in this case, Cu See, this is the compound. Okay, this much about the classification of ligands.